Good afternoon. We're going to start with, it is afternoon, isn't it? Good afternoon. Uh, what would be the orientation of the figure L after a translation of 8 units to the right and 3 units up? Before we answer that question, can somebody tell me, give me a pretty quick definition of orientation? Yes, I'm recording. Good. What is it? I mean orientation. Orientation. That is a word that you most likely will find on the test and not on a situation where Taylor is having difficulties. So I would suggest you look at what we're talking about and not focus on Taylor's difficulties, which are not mathematical in any way. All right. So tell me, what is orientation? If you don't know that word, you don't know the entire problem. Yes. Orientation. Uh-huh. Yes. Ah, the position of it. Yes. So where is it? How is it positioned? Good job. Good job, Candy. You'll get the credit for that. Yes. Okay. So the position, basically, which direction is you looking at, right? How is it placed? Um, and on this one, the L, if it's translated, meaning it's being slid across, then it's not rotating, right? It's not changing any orientation. It's still looking at the same way, right? The position is still in the same way, maybe at another place, but it is still positioned in the same way. So A wouldn't work because that is what kind of reflection? What about this one? B, rotation. And L is probably rotation. Yeah, the other direction, right? Uh, so it will have to be C because you look exactly the same, meaning that you are translating it. Remember that whenever you translate images, they don't change. They stay in the same way that they're looking. All right, so a straw has a diameter of zero point 0.6 centimeters and a length of 19.5. What is the surface area of the straw to the nearest tenth? Uh, what is it? Y'all got D. Anybody get anything else? I'm not gonna go over it with a calculator. But here's the thing. Generally, they tell you if they're asking for the lateral area or the total surface area. C gives you the lateral area. This one gives you the total surface area, right? But it's not really specifying it here. So I would assume by the word surface area that it's talking about the area of all the surfaces, right? But in the book it says it's C because it's going just by the lateral area. However, I do not agree, and I think it's D. Because D includes the area of the two little circles, right? A straw would be kind of like this if you extended it. And then you have the one circle here, right? So when you roll it up, then you get the area of that when you find the circumference, multiply it by the length, and then find the area of each of those little circles, add them all up, and then you get your total surface area, right? How many of you got this one right? Yikes. Oh, the majority of you good. Be proud, come on. What about number one? That should have been 100%. Good. All right. In what quadrant would the triangle be located after rotation of 270 clockwise about the origin? Before we answer that question, we need to understand which way the quadrants are numbered. Counter, right? Counterclockwise. And somebody asked me, well, it's saying to go clockwise, so that changes the quadrant. Do you think that changes the quadrant, the way that you rotate? No, because the quadrants are part of the Cartesian plane of the plane, not part of the figure, right? The figure just happens to be on it. It's like the streets. It doesn't matter where we go. The streets they're stationary, right? They don't go anywhere. They don't change unless somebody changes them. But they're there. It is what changes is where you are, your car. Where is it going? That's what changes the direction. So those are the names of the quadrants. If you were to rotate this figure 270 clockwise, what would you end up in? Quadrant 4, because it will be here if it was 90 degrees. It was here, it was 180, but it's 270, so it'll be in quadrant 4. Good job. How many got this one right? What? Okay. What? Maybe I said this is the first image, the second image, and so on and so forth. But yeah, the quadrants do not change. Please keep that in your minds. The quadrants do not ever change. Never, ever, ever. Now, this one brought us back to old school stuff, right? The very first things that we learned. Yes, way back in August, like about 8 months ago or so. So a long time ago when y'all were 12, I think. Oh, darn it. What am I doing teaching 12-year-olds? I'm going to go to college. All right, so good. I'm glad you're growing up. I hope your brains are getting better, brighter, and so back to this. Which rational number is greater than negative 3 and a third? Yikes, over here. And negative 4 over 5. Yes. Why do you think it's D? It's between those two. So how can you prove to me mathematically that D is between negative 3 and a quarter and negative 1 over 4? You mean a mixed number? What is this kind of number? Improper fraction. So when you turn it into a mixed number, what do you get? 4.4? Negative 4.4, right? And he says that it is greater than that, but less than negative 4 over 5, negative 3. That makes no sense. Yeah, it is. Makes sense. This is like, yeah, but less than that. But if you're going this way, it's less that. If it's that one, it's greater. It makes sense, yeah. It has to be greater than negative 3 and 1/3. Which way is it greater? To the right or to the left? To the right, correct? Because the numbers get bigger to the right, and they get less to the left. So it has to be between these two. And negative 4 is smaller than negative 3 and a third. So another thing is that you have to understand what rational numbers are. And let me go over this very quickly. Rational, what are whole numbers? No decimals, no fractions, just whole, right? 1, 2, 3, like counting numbers, the ones that you count with your fingers. But they include 0, right? And there are no negatives. What about integers? Do they have decimals? No, they have fractions. No. No fraction, no decimals. They're basically a reflection of all the whole numbers. They include all the whole numbers, but also the reflection of the negative side, right? So it'll be the same thing, negative. It'll be 0, 1, all the way to infinity, and then from negative 1 all the way to infinity on the left. That's why I put it in purple. Imagine the numbers are it just includes all of them except for the fractions and the decimals, right? And of course the rationals. What about rationals? It includes everything, not all kinds though. Every single rational number is in it, right? So like all the whole numbers, all the fractions, all the decimals, any number that you can put as a ratio of one number over one number. In other words, a number that you can turn into a fraction. That's what we call it rational. What about irrational? Pi. And what else? And the square root of negative 7, right? Not 7, the square root of negative 7. 70 is a whole number. Uh, so irrational are the ones that just keep going forever and ever and ever, whether they repeat or not, right? Well, no, if they repeat, that's a different story. But the ones that don't have any patterns, those are the ones that are irrational. They're just crazy numbers. So let's first go over here and plant this one. -3 1/3 is about right here. And -4/5 is almost close to -1. Let me see actually between those two, right? Greater than this guy, but less than this guy. So D actually lands over here. 0.4 lands over here. 0.19 is even closer to 0. The only one that is not is B, which is 7/9, which is about 1 point something, right? And that one is actually farther down, and it's right here in between those two. So the answer will be B. Be very careful. Be very, very, very careful. Use a number line every single time if you ever in doubt. Yes, go. All right, the next one. Which of the following is not true of a trapezoid that has been reflected across the x-axis? Let me circle that, x-axis. Before we continue, what happens when you reflect across the x-axis? To the numbers, what happens? You keep all your x's and your y's change, right? All right, well, let's try it. The new trapezoid is the same size as the original trapezoid. Is that true? Yes. Why is that? It's just reflected, right? It's an exact replica of the first one. The new trapezoid is the same shape as the original. True, we just defined it. It's reflected, therefore it's congruent, it's exactly the same. The new trapezoid is the same, it's in the same orientation as the original trapezoid. What do we reflect? So is it looking at the same direction? It's not? Okay. We're going to keep that one. Let's go to D. The x-coordinates of the new trapezoid are the same as the x-coordinates of the original trapezoid. Yes, we just saved them, right? Let me visualize this one. If we're reflecting across the x, let's pretend that it's it's a trapezoid, right? Like that, trapezoid. Then it's going to be looking this way, right? If we reflect it. Then the orientation changes, right? Because it's now facing down. Yes. A trapezoid, that's just the name for it. Or a trapeze, when you hang from. Oh, maybe that's why. I know what you mean, but you know what have you seen those things that the circus people use? Like when they hang from here? When they hang from them? That's all I think of. Because if I close this, what does it form right here? I don't know if there's any relationship between those two, but to me, that's what I think of every time that I hear that word. Of course we're recording. I'm sorry? I think it's a trapeze. Yeah? Trapezoid, trapeze. Trapezio. A trapezoid. It makes sense. To me, it makes sense. Okay, so the answer is C. What would happen if we reflected across the y instead? And this was a trapezoid that was not equilateral, isosceles, meaning that both sides are exactly the same. Would the orientation change? No. What do you think? Wait. What do we had? A trapezoid, like this one is equilateral. See? Exactly the same. and we reflected it across there. Okay. Well, is the A in the same position before as the A was? Oh, what happened? It flipped right, so the orientation is actually different. Careful, careful, careful. It's, when it's a translation, then the position doesn't change, right? All right. The next one, a triangle with coordinates blah 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 and blah is translated 4 units to the left and rotated 180 about the origin. What are the new coordinates of this image? Let me erase this guy because um he's just hanging in there, quite literally. So this is the type of question you will see on a test where you have more than one action. You have to do first the translation and then the rotation without graphing it. So what I would have done, I don't know, what did you do? Did you do it the way that we did it yesterday? Use the rules. Perfect. Perfect. So let's say we have 6, 4. Why did I write 4? And then we have 2 and -1. And then we have 3 and negative 3 and 5, right? So what is the rule here for the? What is the rule here for this translation? Subtract x by 4. Do we do anything to the y? No, we're not moving up or down, right? We're staying in the same position. So we just take away 4 from all our x's, and that gives us our new coordinates, right? You take a step at a time. You don't do it all at the same time. Now we rotate 180, and the rule says to multiply what? Yes, each coordinate by -1. Do we flip them? No. The rule does not say anything about flipping them, so we just multiply each coordinate by -1 and multiply by -1. What is an easier way of just saying that? Other than saying multiply all of them, what do you do? Do what? Just change the sign, right? Just change the sign of all of them from whatever it is to the other one. So this will be -2 and -4, +2 and +1, and then +7 and -5, right? We know that we're multiplying negative by a positive, we get a negative, negative by a positive, we get a negative, negative by a negative, we get a positive, and so on and so forth. Yes. For you guys, it's different. I mean, for mine, it's wrong. It's whatever you got. It's supposed to be letter D, and you should have gotten this one. My book is stupid. It's not stupid. It's just incorrect. I don't know why. And it's the teacher's book. I know. Well, duh. How is that even a question? All right, for the next one. Solve the equation 3y plus 17 equals -3, 2y plus 25 for y. Well, this takes us back about a month ago when we did all this, right? Multiple step equations. We remember all this. We know that we have to do the combine the variables, blah, 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 blah. Easy stuff. Like for you guys, it's like, I can do this, my eyes closed. So we combine variables, 2y, 2y, we get 5y plus 17 equals 25. Then we add or subtract. Obviously, we're going to subtract 17. And then we get 5y equals 8 divided by 5. And you get y equals what? 1.6. Do not forget to bubble in. Otherwise, on the test, it won't count. All right. I am recording now, so we're back from a little break. Y'all don't because you're here. However, my first period does. Trust me, they do. Hey, y'all, first period, they don't believe it, but yes, they do. And I know that because I get questions like pertaining to these things that you could have only heard in this class. So trust me, they do watch this stuff. Um, the what? 366. They are on YouTube. Armor Gurr, where you've been the whole semester and a half. All right. For each pair of corresponding vertices, find the ratio of the coordinates and the ratio of the y coordinates. So, what are you going to do here? What does that mean? Find the ratio of the coordinates. Let's focus on the word ratio. What is the ratio? Nothing to do with the coordinates. The word ratio, what does it mean? All right, here's the thing. When I ask you questions like that, I don't mean start guessing. I mean start thinking. Start thinking, what does the word ratio mean? Where have I used it? Don't just throw things in there that don't make any sense. I want you to think about what you're thinking. All right? Tabaria, what is a ratio? A rate. Okay. That's a good. What else? Constant rate. What else? You're comparing two things. So what? That's a good example. What else? Yeah. What? Not necessarily the average, but we do have two numbers, and it is a proportion, right? We write it as a proportion. So in this case, a ratio would be, we have a, which is the x coordinate, is at 2, right? Negative 2. And the prime coordinate is at negative 4. What is the ratio between those two? How do you say this? So, so for rice, when you're cooking rice, usually say for every 1 cup of rice, you use 2 cups of water. What is the ratio? 1 to 2, right? 1 to 2. So you multiply by 2 to get the water, right? So if you use 2 cups of rice, how much water do you need? 4, right? Basically double it. That's the ratio. So it is a rate. It is a proportion. It is a fraction. It is whatever things that you said all put together. So you should always ask, in this case it says, for that number, you should get that number. How do I get from negative 2 to negative 4? What do you do? By what? You multiply by 2. That is a scale factor, right? We went over this last time. That means the ratio would be 2. And then what about the y coordinate? For a. The y coordinate right here is 2. And then for 4, for this one is 4. So how do you get from 2 to 4? You multiply by 2, so it will be the same thing. What about for b? The x is 2, and then it's 4. Multiply by 2. What about for the y? It's 1, and then it's 2. What about for c? The x is, let's go with the y. The y is negative 2, and the x, and the y for the c prime is negative 4. So what do we do? So we have basically proved that the whole thing expanded by 2, right? You multiply the whole picture, all the sides, all the points by 2, and you get your new one, right? I told you that how simple it is when you're doing dilation. So simple. All you're doing is multiplying by the same scale factor every single point, and you get your new image. That's all you got to do, literally. All right. So blah 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 blah. I don't like that. The scale factor of dilation is 2. All that mess for what we already explained before. How can you find the scale factor of a dilation? I just showed you one way, right? What is another way to find the scale factor? What do you divide? The image divided by the pre-image, right? and you get the scale factor. That simple. Divide the image by the pre-image, and that gives you the scale factor. Do not forget that. Because sometimes they're going to give you the points of the image and the points of the pre-image. I'm sorry, pre-image and the points of the image, and you have to figure out the scale factor. So make sure you understand that. This isn't really new. We've done it before with proportion. I'm also going to post the one about similarity because similarity is extremely similar to dilations. Oh, that fine. All right, so that's what we just did. Move on to the next page. This is your homework. That page 367. And we're going to move on to the next part. Hey, we're still working. We're working on the back part. Find the scale factor. Hello? Are we all here? I want you to find the scale factor for figure 17 and 18 individually. Using what I just told you of how to find the scale factor. Yes. Hang on. Stephanie, how did you get the scale factor of this thing? Come here. Okay. Resourceful. Okay. How do you know that from A to B it was 2? Wait, from A to B right here you counted this? Okay. 2 units you mean? Okay. On prime, So what did you do with those numbers? The new one, yeah, the new one on top and the pre-image at the bottom, right? So what happened? Yeah, you divide and you get 3, right? So you can say the scale factor is 3. That's one way to do it, and generally it always works. So what is another way to find the scale factor besides looking at the lengths? Find the point. So give me one coordinate from here. There has to be a point on one of on the image. So 1 and -1. That's going to be coordinate D, right? That's 1. This is -1 and -1, right? I'm using D. So what are you going to use now? -3 and -3. And -3. You have to use the same point, but the image, right? And the pre-image now. So what do you look for here? You can divide, right? You can put the image, which is the prime, on top of the pre-image, and then divide it. You get 3. Or you can just think, what do I have to do to get from 1 to 3? Multiply by 3, right? But I need you to do that. Put the image, which is the new one, on top, and the pre-image where you had at the beginning at the bottom, divide it, and you get the answer. And that's it. It's pretty simple, right? What about number 18? What did you do? A and B and A and B prime. So what is A and B? So you're looking at 4. And then what is A and B prime? Where does the 2 go? Why does it go on top? It's prime, right? It's the image. And this is the pre-image. So what happens? 0.5, which is the same thing as half, right? So that's one way of doing it. What is another way of doing it? The points, right? Let's use point A. Point A is 8 and 2. And then A prime is 4 and 1. So again, you grab a point from the prime. Let's grab 4. And then a point from the top, which is the image. Divide it, you get half or 0.5. It's very simple, right? As long as you remember to always put the prime on top and then the image at the bottom. And then divide and you get to go. You should. If you understand this, the next section, which we were doing tomorrow, which is just all algebraic, it should be fine. You should be able to figure it out. What? No, we have like 3 minutes. What's wrong with you? We have instruction to continue. Yes. You have 2 minutes to complete letter A. Go. All right, so what are the coordinates for this one? We're recording. Y'all. The scale factor is 2. It's not negative 2. It's 2, right? So negative 2 times 2 is negative 4. Negative 2 times 2 is negative 4. That's it. 8? Yeah, because you have, no. It's 2, 2, 2, 2. It's 2 all around. So it's 2 away from each. That's 2, and 2 is 4. So it's 4 plus 4 is 8. Plus 4 is, should be 16 total. Yeah. The second one, it'll be 8 times 4, which is 24, right? It kind of doubles to the perimeter. All right. Don't forget your homework.